Welcome back, everybody. Well, I know it's been a while. It's time to get back into the Cadet here. Couple updates since the last time I left off. Got a few new parts in here. Got the 3/4 inch round stock, which will make the upright portion of the brand new spindles that we're making. And I was looking a bit closer at the old ones and didn't realize till the other day. So these plates, which are welded to the spindle, that's where the ball joint or the tie rod goes. This is how it should look. There's one bend right here, and then it bends back right here. So it sort of forms like a dog leg kind of shape. And I realized on this one has a pretty good hump in it, and that's not how it should be. So this thing got jammed on something at some point. That's 1/4 inch plate too, so it's not that light. So my options were to grind these ones off and reuse them, or easy enough in my case, I just designed some new pieces here, had those water jet cut out, and those are also 1/4 inch, so I'll need to mark off the bend lines, and we'll get these bent to match the originals. I did buy one more ball joint end to replace the one that was damaged that came off the tractor. And I think we're about to the point now where we can start machining on these spindles. So I got a center punch here and some drill bits. Go ahead and locate the punch marks on both of these. We'll take these up to the drill press and we'll see how it goes from there. One step closer. So again, here's that brand new 3/4 inch round stock. This is mild steel, so it's easily weldable, but I went for a cold formed or a cold drawn finish. It's very smooth, as you can see, so it's going to be a nice substitute for the original 3/4 spindles there. So let's go ahead and get these holes marked off. All right, to kind of show you here what I'm thinking, at least my plan, I have not set the camber angle just yet. I think we'll take care of that here in a minute. But here's a sketch of the spindle. So you see right here, there's a portion of the journal, and it's a much better finish than what's out here. That's where that grease seal rides. So seals typically use a pretty fine surface finish to work properly. So we want to stay off of that journal. And again, this is a 3/4 inch shaft. So we'll be drilling pretty much a 3/4 inch hole out here on this stock portion of the spindle. Because of the camber angle, obviously we'll need to tilt the table on the drill press, and then we'll drill down through this spindle at a certain angle once we figure out what that angle is. But on the bottom side where the new rod will pass through, I need to leave a gap there, a gap to that line right there, because I'll need to weld around the bottom of that. And I think about a 1/4 inch gap will work or so. I might cheat that to be more conservative. But so we'll find out what angle we need, and we'll do the math and kind of back off there to keep our 1/4 inch gap. And I think I'm going to punch mark this side, and then we'll drill through this way. I think I can hold that closer than starting on this back side, drilling through at some certain angle, and then hoping I hit, pretty close to that line or a 1/4 inch off. All right, so to find out what camber angle we need, we'll start off with the axle here. And so these axle bores, I think I covered this in the last episode, they are not vertical or plumb. They're already offset to some degree here. So to find out what angle that is, or to come very close to that, take our 3/4 inch round stock, I'll drop that in. I've checked my workbench, and for what we're doing here, this will be just fine. So that's about 1/2 degree right there, which is plenty good for what we're doing. So just hold my phone up here, and yeah, we're roughly between a 7 and 8 degree angle. So it looks like about 7.5. So we'll call that 8 degrees. So that's going to be our angle for what our axle is. And so if we wanted our front tire to be perfectly plumb, that is pretty straightforward. We would just drill our hole at an 8-degree angle, and when everything is said and done, this tire should be plumb. But I mentioned in the last video, I would like to give this tractor, or these front tires, a bit of positive camber. So I want to take the top of the tire, and it's going to be kicked out a little bit, just like this. So I need to find out how much additional camber I want to do that. And in order to do that, I'll get one of these tires mocked up on the bench here, and we'll take a look. All right, I think I landed on 4 additional degrees to give me a 4-degree actual camber. Sort of something I just looked by eye or by feel. Nothing very scientific about that. I know I just did not want this tire to be perfectly plumb. So that means about 12 degrees total, 8 to account for the axle angle, and then again 4 more gets us to 12. So someone out there might have an old I&T manual for these older Cub Cadets. I couldn't find anything online. I'm thinking it's in that 10 to 12 degree range, but my plan is we're going with 12, and hopefully it works out okay. We'll see. Okay, so I found out that I need 5/8 of an inch of an offset to my punch mark. To be safe, I'm going to go an extra 1/16 of an inch, so that's 11/16. And this is not that critical of a dimension, so a tape measure will work just fine in this case. So I'll come down to 11/16. And if you're watching from anywhere else other than the United States, you're probably wondering what that is in metric. But anyway, 11/16. When this rod passes through that point, it's going to leave me, in theory, 5/16 of an inch clearance, which should be plenty for a weld. I definitely don't want to weld on this portion of the spindle. So I'll get a punch mark located right there on my mark, and I'll get the other one done also. All right, we got both spindles punched. Let's take these to the drill press and start drilling. All right, we are all set up on the drill press, ready to go. In the Craftsman 20-inch press, the table is set to 12 degrees from the horizontal. There's an indicator right back here, so that's set 2 dashes past 10. So right there at 12, make sure to check that the spindle is parallel to the table. The vise is clamped down, everything is set. I have a center drill bit in the truck right now. I'm going to use that to start on the first pass here. One more thing I'll say, I wanted to keep the hole for the cotter pin out here pretty parallel to this new hole I'm drilling. That way, when I put the cotter pin in, I can put it down through if it ever broke or came loose. At least it can't come up through and the wheel couldn't come off. So just a little thing there, really not a big difference, but I'll show you one quick trick. Got this pretty well centered, trying to do this here with one hand. So I checked, of course, that the center drill bit touches off right there in the punch mark, and we're good to go. I actually used a razor blade, laid that across the top surface there and ran this center drill down. And you know you're pretty close if that razor blade wants to stay level and not pitch off to the side. And here's what I mean by that. It's a quick way for you to check something like this. Make sure you're close, hold the blade down there, and if you push down, you see how it comes up flat. So it's telling me it's pretty close to being where it needs to be, and I'm still hitting the punch mark there. So we're all ready to go, and we'll see how this goes. say we're about done with that center bit. So you can see we got a nice hole opened up there. I'll swap that out now for a 3/8 bit. Alright, 3/8 bit is in. Looks like everything is still lined up. I'll admit, first time really drilling on a round shaft like that at an angle. So 12 degrees isn't much, but it's enough to just make it a little bit difficult. Alright, we are through with the 3/8 bit. I'll go ahead and switch that now to the final bit. I'm going straight to 3/4. I have a shorter 3/4 bit, so hopefully it shouldn't want to deflect, too much. But that 3/8 bit cut pretty nice. It was definitely pulling the metal out of there. That 3/4 was just a bit too big. I probably figured that, but didn't hurt to try it. The problem is, because I'm at this angle, one side is cutting on that larger bit and one side is not. So there's a lot of chatter. So I think kind of stepping it up step by step just to keep the cutting depth down to a minimum should work. But we'll keep working our way up to 3/4. Alright, we're making some progress now with the 3/4 inch bit. I'd say I'm roughly 1/4 inch deep right now, but it's finally starting to cut and smooth out, so we'll keep going. Alright, here's the finished product. Pretty happy with it, how it came out. That hole is nice and centered on that spindle. That was a lot of drilling. I knew it'd be a job, but we got it done. And we'll need to do one more of these. And let's do a quick test fit. We'll slide the 3/4 round stock in, and pretty happy with that. It's a nice fit, should work just fine. Again, that was a straight 3/4 bit. I did not ream anything. That's just the as drilled finish. Should work. And now let's do a quick fit up of one of the front tires on the tractor using that new spindle. Alright, here's the setup on the tractor. Now, because I have the front end blocked up on cribbing, I had to make sure that the axle was sitting level to get the correct height. And also I accounted for the tractor frame being raised with this piece of plywood, which is below the front tire. So this kind of gives you an idea of how it's going to look. I'm not going to lie, I think it's a pretty aggressive camber angle. I'm thinking maybe 10 degrees might be a bit more ideal, but 12's not bad. I probably wouldn't go any more than that. Again, this is actually 4 degrees from the vertical, so probably 2 to 4 in that range. I did do a quick check. I have a 4-foot straight edge. I laid that up against the back tire there, kept that parallel to the tractor frame to kind of gauge where this front tire falls. And the tread width falls well within that straight edge. It pretty much goes clear out to the sidewall, and because this tire is a bit stretched on the rim, that's fine. It actually puts this tire on the outside, the outside corner or the edge of the back tire. So I think we bumped it out roughly 1/2 inch from where it used to be, and there's plenty of clearance in here to the hub, to the spindle bore or the axle. Again, I wanted to keep enough room down there in the bottom for that weld, so it makes it look like there's a lot of room here at the top, but there's just that 1/4 inch at the bottom or so. So not too bad. I think it looks okay. But let me know what you guys think. If you have an opinion, it might be hard to tell on camera. I'm standing right in the middle of the tractor here. I think the camera makes it look a bit more tilted than it actually is. But it doesn't look too bad. But let me know before I machine the second spindle, should I stay with a 12 degrees total or cut that back to 10, and then I would have to buy one more spindle and then machine that one. But on the positive side, I think having a camber like this is only going to improve the handling of this tractor. You know, bumping out the front tires half an inch each way just improves, you know, stability, not by much, but gives that front end just a slightly wider stance. And then I think it's going to steer much easier, one because of the tri-rib tires. That always helps, but then I think that camber will help this thing handle a bit easier. And there should be enough work here to keep us busy. If you noticed at the beginning of the video, you may have seen this piece of sheet metal laying here on the bench. Finally, after 2 years, I'm getting around to making a brand new bumper, which was a factory option from Danco to go with this front loader. So a gentleman about 2 years ago sent me most of the dimensions for this, and I finally was able to get it designed, make a drawing up for it, and have a fabrication shop cut this out and also do the forming. So very happy with how this turned out. It's nice and heavy duty. It's 11 gauge, so almost 1/8 of an inch thick. And we'll need to work on getting this bumper mounted to the front of the tractor. There are 2 sheet metal angles, and those are bolted on. I'll probably take those off, set those to the side, and I'm probably just going to get some angle iron, some steel, and just cut my own pieces, and I'll weld those new pieces to the bumper, and then I'll drill the holes so we can mount that to the front end. So that's why the pump's back on there, just so I can mock this up, but we will be getting into this, and it's going to help complete the look on the front of the tractor. So pretty excited about that. One more thing I will show you here, sort of a preview to an upcoming episode. If you remember, this tractor was missing the front grille, and it's one thing I've always wanted to replace on this tractor. But instead of buying an original grille for about $75 or so, or I'm sure you can find it, you know, for less money at a yard sale or something, I thought, why not design a custom grille? And I've had this in my mind ever since I bought this tractor, and just something that I wanted to do. So let me grab the grille that I got in, and we'll get it bolted in. And here is the custom grille that I designed and had made. So this is a 3/16 thick plate. As you can see, there's a bunch of round holes cut out in it. And so this was my plan for this tractor all along, just to do something custom and unique looking. And International Harvester, around the same time period in the early to mid 60s, they're industrial tractors made for industrial uses on construction sites and more heavy duty applications rather than just farming. Most of the tractors had a grille of this style. So just something unique. Let's get that bolted in, just hand tight, to see how it's going to look. All right, we'll just put this together, and I'll only use 2 of the 4 bolts to get this mounted. Just want to show you how this is going to look. So put these 2 bottom bolts in, and we did get all 4 of the drilled and tapped holes on the casting cleaned up, so these bolts went in no problem. Let's stand this up and take a look. there you have it. I think that looks pretty awesome, actually. I'm excited to get this back onto the tractor. And of course, I'll have the headlights up top here. But I think that looks great. It's going to give it a unique look. I've never seen a grille like this on a Cub Cadet. I'd say it's one of a kind as far as I know. But it's going to give it an industrial look. So looking forward to getting that on there. And now that the cast iron nose piece is all ready to go, all 4 of the holes are clean and good to go. We can get that back on the tractor at any point now. I think I want to do that pretty soon here. That should not hold me up anymore with doing the steering. And I want to get that nose piece back on here because I want to start planning out how I want to do my new exhaust system. That's something else that I want to do here, but until I can get that on there, I won't know how much room I have to deal with. So as you can see, there's still quite a lot of work to do here. To address one question or comment that was left down below on the last video, no, I'm not going to be doing a complete teardown / restoration right now. That was never the intention. I just want to do a couple of these upgrades and modifications and try to work toward getting this tractor more mechanically sound and sort of optioned out how I want it to be before I'd ever do, you know, a major teardown and paint and everything like that. Someday, yes, but not right now. Anyway, leave me a comment down below if you have any comments or suggestions about that front wheel with regard to the camber. I'd appreciate that. But I think I'm going to end this here. As always, I appreciate you watching. I know this video series kind of drug on there the past couple weeks. Finally got some time again to work on this thing, so we'll try to keep moving, and I appreciate you watching.